Hey everyone. So welcome to this lecture on variables and data types, right? In the Python for Beginners course. And so what we're going to do is look at the different types of variables and how data types work in Python. In the previous lecture, we kind of covered the first, writing our first Python line of code in Google Colab. And then I added a lecture on that on how to set up Python using Anaconda and Jupyter notebooks, right? And so from this lecture on, till I kind of say otherwise, we're going to be using Jupyter notebooks. So get ready to spin up your Jupyter notebooks and let's go. Okay, so we've spun up our notebook. Let's get started. So the first question is, what are variables, right? So the answer is quite simple. A variable is a container, right, that helps you store a value. So for example, in Python, suppose you want to just find the difference of or the product of two numbers, 2 and 3. So you could say, well, okay, 2 times 3, right? And you say, and you're right, you get 6, right? But what if you want to write something slightly more complicated? And so you want to kind of keep this in a structured way. So what you do is you'd probably say A is 2, B is 3, and then you say C is A times B, right? And then when you say print C and the print function from a Python 3 point plus, it's print is now a function and not a statement. So and we'll cover print in more detail in a future lecture. But basically, so if you say print C, it gives you the same answer, but now A is stored and can be accessed. The value 2 can be accessed with A, the value 3 can be accessed from B, and product can be accessed and is stored in C. So if you say C now, it gives you the answer, which in this case is 6. So as you can see, a variable is a interesting way or is a way to store, values, right? And then you can call or kind of get that value back when you need it using the name of the variable. So simple question, why do we need variables, right? You could just have said 2 times 3. So the answer to that is it's very easy, right, to use, variables in programs. It makes it easier to use values, right? And so you could have values that are used in multiple places. You might have values then that show up in different points and need to be changed. And by using a variable, right, you can reference that value again and again without actually having to use the value name. So let's write a simple example, right? Let's say you want to compute interest on two deposits, right? And so you're saying, well, okay, the interest rate is right 20%, and so I'm writing this point two, right? Now let's say deposit one, the amount is, so interest rate is a variable, stores the value 0.2. Deposit is a 1. Deposit 1 is a variable, it stores um, value 1000. And then I say interest 1, which is basically the interest on deposit 1 is now deposit 1 times interest rate. And assume the interest rate is annual, right? And the deposit value is annual, right? Keep it simple. Let's now say you have a deposit 2 in the same bank. Now the value is 2000. So what is interest 2? Now you could say again deposit 1 times zero point 0.2. You could say deposit 2 times zero point 0.2. Easier to say, well, deposit 2 times interest rate, right? And now if I print, right, interest 1 and interest 2, well, let's print it separately, right? Let's say, let's just write the code a little cleanly. So let's say just 1, right? And then let's say print, right, interest 2, and I say print the value, right? So let's go, right? Okay. So interest 1, interest 2, I've left next to space. And you get the answer, right? 0.2 times 1000 is 200, 0.2 times 2000 is 400. Now, the advantage of using this is if I change the interest rate, suppose the bank changes the interest rate to 0.15, right? You just change the variable name and you've seen your calculation values have changed, right? So the advantage of using a variable is in a program, now you know interest rate is this value. You can use it in different places. And when you change the value here, it changes everywhere. You don't have to go back in and change. Whereas if you had said 0.2 here and 0.2 here, And when this became 0.15, you have to go back here and manually change wherever that value shows. Right? So it's a very nice, clean way of kind of storing and then retrieving values. And so variable identity, which is obtained by saying ID, gives you where that variable is stored. So for example, if I say interest rate and I say ID, it gives me this, which is where the interest rate is stored, right? Okay, good. And so as we're seeing, variables now have names, right? Different types of names. So what are the examples of variable names that are valid? Well, the variable names in Python has to start either a letter or an underscore. So something like is fine. You could also just say ABC equal to 1 is fine. You could have a capital letter ABC, and that's also fine. What if you start with a number? So if you start with a number, Python says error. Right? It doesn't understand. So you cannot start with a number. You can add a number in the variable name. We just did that with interest rate. You can add that number in between, but you cannot start with a number, right? Also, if you say A is 1 and then capital A is 2, and you just let's see what happens when you print A, right? Sorry, I didn't complete typing. So what if you say A, and then what if you say capital A? Right? And you see they're different, right? If it had been the same, then you would get the same value for both. So capital and small are different. But if I use a special character, so if I say A hashtag is equal to 1, what happens? Right? Hold on, let me just change this 1 second. Say hashtag equal to 1, and then let's just, well, hashtag actually is for comments. So we already know that's not going to work. But if we say A at equal to 1, and then I say I print A at again, right? So special characters clearly don't really work in variable names. So we understand that variable names must start with an underscore or a letter, can contain numbers but cannot start with a number, and capital and small are different. Okay, fine. Now the interesting part of Python is typically if you're familiar with C or C++, right? Um, if you say a variable A, right, is 1, you have to tell it it's an integer, right? You will have to, if it was C, you would have to say int A, and then you'd add a semicolon if it was C or C++, right? But you'd have to tell it. In Python, if you say A is 1, Python understands it's an integer, right? And so if I, how do you find out what type it is? So we can use the type function. And so if I say print type A, right? And it tells you it's an integer. Right? And so it understands that, but now if I say B is 2.0, and if you add the decimal, it becomes a floating point number, right? Or a decimal number, right? And decimals are definitely called floating point numbers. So if I say type B, it understands B is a floating point. So Python, by default, depending on the value assigned to it, it understands and it understands what type of a data is stored in it. You don't have to tell it explicitly that what you're storing is an integer or a floating, right? Okay. Now, like we just did above, you can check the type with type. So we just did type A. So if A is, let's just try another one. Let's say A is, let's A is hello, right? And so say print type A says string. What you can also see here is if you assign a value A and then I change it, right? So I now say A is hello. It's replaced this A equal to 1. Now it's A has become a string. It's a different variable now. It's the same name, but it's different now. and the value is it's a string, right? And the value in it is hello. So in Python, what you can do is if you define a variable as something, you use the same name again, you can have another value in it, and it could be a different type, and Python understands that. And what you can also do is use is instance and ask it what the data type is. What's the difference? Well, in the first one, it tells you what the data type is. When I say print type A, it tells you it's a string class str, right? On the other hand, if you say is instance, you have to ask it what type it is. So if you say is instance A, right, and then you say string, right? So str, right, it will say, actually, my bad. It needs to, you need to remove the, um, yeah. So it says true. On the other hand, if I say, because str is the data type, which is string, on the other hand, if I ask it if it's a float, it says false, right? So if I just comment this out. So this instance is a way for you to check what type it is, and it will tell you true or false, right? So it's not a float, and it is okay. So you've understood that there are different data types in Python. What they are, we'll now cover, right? And you can understand how to check what type of data it is. Okay. So let me just say variable slash data types. So the first is an integer. So first, as in the first one we're going to cover. So it's an integer. So if I say I is equal to 1, and I say print I, and then type, we've just covered type, right? So you know what it is. So type I, it will tell you the value is 1 plus is an integer. So an integer is a number without a decimal. You don't give it a decimal, it understands it's an integer. So if you just say 32, it's an integer. Where do we use integers in Python, right? So you use it to count, you use it to give an index. So it's the first element of something, of a list, let's say. And then if you want to do integer arithmetic, you want to add two counts. So there are 5 people in one class, there are 7 people in the other, how many people in the school? So you want to add those numbers. You don't need floating points for that. You don't need decimals, right? So you use integers. So for example, right, let's just say, you have a class and you have marks of students. So you say, I'm creating a list here. We haven't covered list, but it's basically just a way to add multiple elements together. And so I said 3 students' marks. One has got 90, one has got 100, and one has got 85. Now, if I say print and I use a function called len, which we'll cover when we get to lists, but it computes the length of this list, right? And I say n marks, right, is len marks. So n marks should tell us how many elements are there in this list, right? How many different marks are there. And I say print, right, n, and then our favorite function type n marks. We get 3, and we get that is an integer, right? So it's a really nice way to store values that are integer values. So length of something, count of something, right? So for example, if we add a small loop, we haven't covered the false statement in detail yet. We've just introduced it in the previous lecture as an example. So what this does is it says it kind of just iterates. So basically runs the same code 10 times. And each time it runs the code, I is the count, right, of how many times it's run the loop. And so if I say print I and then type I and I say go, you see I is 0 and it's an integer. I is 1 and it's an integer all the way to 9. Right? And so it's run it 10 times. It doesn't get to 10, goes from 0 to 9, and you get the type. So you see how, again, something that is used in a loop to keep the count is an integer. So we've seen examples of integers. If you add two integers, so if I say, I is 2, j is 3, and then I say k is I plus j, and I say print k, and then type k, What you get 5, and it's an integer. So again, simple arithmetic. 2 could be a count of something, 3 could be a count of something else, and you add, you get the same number. You get an integer. So that's one type of data in Python. The other is the floating point, which is basically a number with a decimal. So if you say, num is equal to 20.0, right? And then you say print. So we're using the print statement a lot. And then you say type num, it's a float, right? So if I take this decimal out, what it becomes 20 is an integer. So the moment you add a decimal, it becomes a floating point number. So where would you use a floating point number? Simple, right? Calculations is the best example. So let's say you have an example here. Let's say you're selling t-shirts, and the cost price of a t-shirt, meaning how much it takes to manufacture it, is 100 rupees, right? Let's say you want to add a profit margin of 20%, right? You're a good business person, you say 20% profit margin, right? So what are you going to do? You're going to say, now I want to calculate the profit, actual value. Say profit, right, is cost price times your profit margin. And so now I've got two variables here, cost price, profit margin, and now profit is another variable that stores the product of these two, right? Cost price and profit. What do I do? Let's just print profit and see what we get. So you get 0.2 times 100, which is 20. So you've done a simple calculation and you've used floating point for that, right? Because you want a decimal value. And then what you do is you say, I'm going to add now. So I'm going to say selling price is equal to cost price plus profit. And let's print selling price. So now selling price is another variable. It takes the sum of cost and profit. And so both are floating points. So it stores a floating point and the selling price now. And so I can just add a small label here. I can say profit. And I can say, right, selling price. It's 120. Now, what's the advantage of using a floating point? Well, what if I made this slightly more interesting? What if I said it's 0.235? So now your profit margin is a slightly more complicated percentage. It's 23.5%, right? Now what do you get? Well, if this wasn't a floating point, because 23.5%, 0.235 of this is actually 23.5, right? So now you have a decimal. So an integer would not be able to have that decimal, right? You wouldn't see the decimal. And so that would not be represented. But now because you've used a floating point, you can see the decimal. And so if a decimal shows up in the calculation, Python is going to treat it as a floating point. So even if I make the cost price an integer, right, and let's just print type cost price, right, and then I'm just going to add here type profit, and I'm going to add here type selling price. What do you get? Well, cost price is an integer, but now because it's multiplied with a floating point, your profit now becomes a floating point, and your selling price becomes a profit floating point. So Python understands that actually, even though the cost price is an integer, with this calculation, it needs to make it a floating point. It needs to make the calculation a floating point calculation. And so you can use decimals. So that's the second data type we've covered. The third is complex numbers. Now, complex numbers is something you might not typically see unless you're doing a lot of math. But basically, what you can do is represent a complex number with two parts. It's going to have the real part, which is just a number, right? So minus 2.0 plus, and then if you have an imaginary, what's called the imaginary part, and you add to that j, right? So if I print c and type of c, you'll get it's a complex number. The complex numbers are numbers that you see in mathematics, typically the j, the complex number, is square root of -1, and that is written as j, right? So it indicates a complex math calculation. It's used in a lot of different, fields, science and maths related. But Python does have a data type called complex, and what you can do is use to get this or this of a complex number. So we got C. If I want just the first part, I can call it's called the real part of a complex number. Now we're not worrying too much about complex numbers because you're probably not really interested in it or going to use it a lot unless you're doing serious computations. But if you say C dot real, it'll give you the first part, the part without the J. And if you say real index is wrong, it's real part, right? An imaginary part, right, is C dot image, IMH. And so the imaginary part is take out J, and what you see here is the imaginary. Right? And so complex numbers are also a data type that you see in Python. What's the next one? The next one is a Boolean. So Boolean basically holds true or false, and it's represented true is 1 and false is 0. So it's a very interesting, very widely used data type because anything you do in terms of comparisons to check for a value, you'll get a Boolean. You'll either get a true or a false. So you can say B1. Let's just say a B1 is false. Then I say print B1, type B1. And so you get the value is false. The class is a Boolean, right? And so what's an example of that? How do we use it? Well, if I just say print, right, 7 greater than 2, what do you get? Get true. I say 7, get false. So it's returning a true or false, and so it's returning a Boolean. How do we know that? So let's change this. Let's say B2 is 7 greater than 2, or 7 less than 2. Then if I say print, right, B2 and type B2, what do you get? You get, well, B2, the value is false because 7 is not less than 2, 7 is greater than 2. And the class is a Boolean. And so you can see how Booleans are used to give you, true or false answers. And so they show up in simple examples like this. And so you can think of another more interesting scenario. Let's say I'm trying to compute the tax for something and say the tax is dependent on the price, right? So I say I'm setting it up initially to say it's 0.0. I'm initializing it, right? So when you say initializing, it's the value you've just assigned first. And then I say I add a small loop. So now these two are what types? They're floating point numbers, right? Because they've got decimals. Now I'm saying if price is greater than 120, right? Then let's say tax is 10 rupees. Else, right, tax is 5 rupees. So first of all, if we haven't covered the if statement in detail, but what it does is it checks this value. If the value evaluates to true, it will execute any block of code here, right? In this case, it's just one line. It will set the tax to 10. If it's false, then it will go to else and execute this block of code. So we can see how you return a Boolean, and depending on what the Boolean is, whether it's true or false, relevant blocks of code are returned. And so if you again check, right, and I say type, and I say price greater than 120, it's going to return a Boolean, right? And the value of it is false because price is 100. So you can see how Booleans, which are returned in different scenarios, allow you to execute depending on the condition. So Booleans are very widely used when you code things up in conditional scenarios, for example. And so it's another data type in Python. And then the last data type, you're thinking none, maybe this is an error in what I've written. None is a data type that's used in Python, right? And so you can say n is equal to none. And if I say print n, and I say type n, you'll say none, and the class type is none type, right? And so none or none type is a data type in Python as well. It's something you can use, for example, to initialize something. So you don't know what the type is going to be. You don't know. It depends on where you're going to use it. You know, maybe you want to set an array, but you don't know the size of the array. So you can just initialize it to none, and Python understands there's a variable there, but right now it's set to none. And at a different point, you can then kind of give it, what it is. It could be an array of size 10 or something like that, and accordingly initialize it or set the value later. And so none does not mean the same as false, right? Sometimes people think it's the same as false. It's not. It just means it's empty. False means false, right? True or false. And so false is actually zero, right? Sets that value. Whereas none is empty. It just says there is no value set here. So there are interesting scenarios where, none is used. And so, for example, let's say you set the value of a to none, okay? And then if I say if a is none, and that's how you check for none, right? You can't say if a, so let's just look at an example. I say if a is none, set a to be 1, right? And then print a, right? And so if I print this before, right, print a and type a, and then I say here print a and type a. Initially, this is the first print. A is type none, and the data type is none type, right? The value is none. And if A is none, which it is, then A is equal to 1. So A gets set to 1, and it's an integer, right? So you can then set it later. It's an example. It's a very simple example. There's not much meaning. Can you do A is equal to none? This is the equal to operator that's used to compare values. So you can say to, right, print. Let's just do this above so that I don't confuse you. You can say print 2 equal to 3, and it will say false because 2 is not equal to 3. If you say 3 is equal to 3, it's true. So this is the way of comparing, right? Less than, greater than, or equal to. Well, equal to typically, as you can see here, is used to assign a value to a variable. To compare, you use double equal to, right? So this is helping you compare. And so if I say if A is equal to none, what happens? Right? So it does understand that we're comparing it. But typically, what you will say is, you will say if A is, right, you'll use that. You will not use equal to. In this case, because the value is none, that works. Typically, try and do is. Okay. And so another area where none is used is if you have a function. And again, we haven't covered functions yet, so we'll do that in detail. But suppose you have a function that takes in two numbers, right, A and B, and you're trying to compute the sum of it. So you say C is A plus B, but you don't return the value. Typically in a function, you have to return what is given back to the user. Now I say D is sum A comma B, okay? And I print D, what will you get? You'd think you'd get the answer C is A plus B, right? And actually here, let's just do something. Let's say 1 and 2. So actually you should get 3, but you don't. Why? Because you haven't returned anything from here, right? If I say return C, right, and there's a space here, then the answer is 3. But if I don't return anything, then Python by default returns none. So when you get to functions, you'll realize that if you don't return a value from a function, right, then again, Python uses none. So we're just seeing examples of the data types. The idea is not to scare you with a lot of complex examples. The idea is just to show you that there is something like none. And that's a data type that's used in Python as well. And just means that there's no value that's been assigned. So these are the simple data types. There are more complex data types in Python. And so you have what are data types, which are sequences, right? And so sequences, as the name suggests, it's a sequence of values. So an example is a string. If I say S and I use the quotes and I say Python is fun. Now I say print S and type S. Well, it's print S, which is Python is fun. And the type is str, which is a string. So string is just a collection or a sequence of characters. Now, if you're familiar with C or C++, you'd have a character data type, right? Which was what was used. Python does not have a character data, right? And so that's a question actually I've left for you later as well. What it has is a string, which is just a sequence of characters, right? Okay. Now I'm not covering string in more detail right now. I'm just showing you the data types because we'll have a full lecture on strings and how you can play around with strings. Same with these three data types. So what you have is a list. We've seen an example of a list, but you can say L1 and you can just assign, a collection of values. So this list, right, will have um, these values stored in a nice ordered way. And the class or the data type is list. Right? And lists need not have elements of the same type, right? So you can have a number, you can have a string, you can have a floating point, right? If you say print L type L2, it's still a list, right? But all the elements are not, these were all integers. These are not. They're different types, but they can be stored in a list. Right? So it's just an ordered collection. We'll get to mutable and immutable just in a bit, right? Now, a tuple or a tuple, depending on how you want to pronounce it, is similar to a list, only you'd use the curly brackets. So here you use the square brackets. Here you'd use the curly brackets, and then you'd say is 1, 2, 3. Same, very, very similar to a list, right? Only difference is it's immutable. So mutable, we'll cover later, means the values can be changed. Immutable means the values cannot be changed. This type T1, right? And so that's a tuple, right? And so it's similar to a list. You can do similar things. So what's the difference? We'll get to that in a again a different lecture where we'll cover lists, sets, tuples, and dictionaries in detail, which will be coming up, next. And so in that we'll kind of go through this because you'll kind of see how to create lists, how to assign, how to index them, and so. What we have next is a set. Now here you've used square brackets. Here you've used round brackets. I think I said curly, but it's round brackets. Now, a set is where you use curly braces or curly brackets, right? And so you would say S1 is 1, 2, 3. Right? And you say print S1, right? S1. And you get it's a set. So what's the difference? Well, the set, right? In these, there's an order to the values, right? Sets are not ordered and sets do not allow duplicates. So if I say S2 and I say 1, 2, 3, 1, and then I say print S2, it's taken away the duplicate, right? It's made it 1, 2, 3. Whereas if it was a list, right, and I said 1, 3, 1, and then I said print L2, the list actually has all the elements. It does not remove the duplicate, whereas a set removes the duplicate, right? Okay. And the last that we're going to look at here is a dictionary, right? And so what is a dictionary? A dictionary is a mapping, right? So here, everywhere, we've just given it the values and the values are stored, right? Straight away, right? In this case, in the case of lists and tuples, in order, right? In a dictionary, what you do is you use what are called key value pairs. So instead of saying just giving it a list of values and then in a say a list, how you would get the value, I guess, right, is you'd say, okay, I want the first element, I'll say L2 and I'll give it the index, right? And so in Python, indexes start with 0. So the first element is 0, the second element is 1. So I say L2 0, I get this. I say L2 1 and I get this, right? The second element, and so on. You do the same for tuples. In dictionaries, you'd give it a key and a value. So you'd say, let's say title. And I'd say, well, variables, data types. And then I'd say, then you add a comma, and then you say next. So I'll say what? Structure. Okay. Instructor is me. And then let's say topic. And so we'll say, well, Python. You could say topic is variables and data types, but let's just say Python. And so we've got a dictionary. Now, if I print D1 and I say type D1, as we always do, you'll get this. The type is dict. Class is dict, which is dictionary. Now, what's the difference? Well, it's how you index the element. Now, if you want title, what you do is you'd say D1 and you'd give it the key, which is the element on this side of the colon. So what you have here is called the key that you give, and what you will get is the value. So there's no ordering. It's just give it the key and get the value, and give it the key and get the value. And so that is a dictionary. So a question for you now, if you just remember what we covered, do we have a character data type in Python? Right? Just think back to what we said. And so let's move on to mutable and immutable data types. So mutable data type, right, means that the value, and it's different, is cannot be changed, right? No, mutable is value can be changed. The difference is this is wrong, right? And so that's my mistake. Sorry about that. Right. And so let me just fix that. Good. And so mutable data type is one where the value can be changed or updated after it's created. So if I say a list is 1, 2, 4, now if I say L1 and I change the second element, or let's say the second element is L1, so that's this number. So let's just say print L1 1, right? Now if I say L1 1 is 5, and now I say print L1, right? L1 was 1, 2, 3, 4. I've changed that, and now L1 is 1, 5, 3, 4. Okay. And if I say along with L1, I say ID L1, and I say ID 1, right? The address hasn't changed. The value here has been updated. Now, what if I change? So in a mutable data type, you can actually update the values. Right? In an immutable data type, so for example, a list we just said is mutable, but a tuple is immutable. What happens now? It says cannot do that. Right? This is not a bug on my end. This actually is it's a tuple or a tuple, depending on how you call it, cannot be changed. So that which cannot be changed is an immutable data. And so, as you'd imagine, things like lists and dictionaries are mutable, right? Because you want to be able to update the values, but the others you do not want to be able to update. So, for example, what do I mean by that? Well, you'd say, well, if I say A is equal to 2, and then I say A is equal to 3, right? And I print this, and say, well, print A first, then I print A again. You get A is 2 and A is 3. So A has changed, right? But let's just do the interesting thing. Let's say ID A. And let's say, right? So it tells you the address of A. And then let's say ID B. The IDs are different, right? Which means it's taken A, you've assigned value 2. When you now say A is 3, it's actually removed the old A, taken A, it's created a new A, and assigned the value 3 to that. So it's immutable because it's not the same variable, right? It's deleted the old one and created a new one with the same name. And so that's mutable and immutable, right? And so integers, floats, booleans, strings, tuples, frozen sets, and complex numbers are all immutable. Lists and dictionaries and sets are mutable, meaning you can keep updating them. Okay, good. So you understand immutable and mutable, right? So one more interesting piece of the puzzle, which is typecasting. Now we've already seen in Python, what is the data type? It's already set depending on what you set, right? So if I say A is 1.0, I say print A and then type A. Python already says while A is 1.0, and it's a floating point number, right? So it's already set the type. But if I now say, so that's dynamically typed, right? If I say, actually, I'm giving it 1.0, but now I say int. So I take int, put this number in brackets. Then it actually says, oh, okay, A is an integer because I've said int and set the type, right? So that's called typecasting, where you can actually set the type. What happens if you do string, right? Now A 1.0, it treats it as a string, right? So by setting the type, by giving it this type specifically and passing that value in brackets, you can specifically set the type of the variable in Python, right? And so that's called typecast. So what's implicit typecasting? Well, in certain scenarios, and we just covered this, if I say A is 1, B is 2.0, what is C, right? And you say C is A plus B, what's the type of? So type A, let's print type B, and let's say type C, right? A is an integer, B is float. It adds these two and it goes, well, listen, this could have some value after the decimal. I've given it 2.0, but it could have, right? And so Python's going to say, well, actually, then C is going to have to be a floating point. And so it, depending on the situation, sets the value or the type of that variable, and that's implicit typecasting. So it understands, depending on the situation, what the type is and sets that in. Great. So we've covered a lot of topics. We've covered what variables are, what variable names are, the different types of variables. How do you find the variable type using type? We've looked at integers, floats, complex numbers, booleans, none type. We've looked at sequence types, so string, list, tuple, and dictionaries. And we've looked at mutable and immutable. And then we've looked at typecasting. Right? Great. Now, when you set up variable names in Python, there are certain words in Python which are called keywords, right? And so the keywords are words in Python that actually define key operations or key, terms. And so do not use those as your variable names. So if you go and say import keyword, and then you say print keyword dot kw list, keyword list, you get a list of all these. And so these are keywords in Python. And so do not do something like false is equal to 3. You do that, it's going to say no, because false is a keyword. It means something very specific to Python. And so you can't create a variable name with that. Same as none, right? It's a very specific, it's a value, in fact, you'd assign, right? Import, right? So you look at the list of these keywords, you don't have to by heart them per se. You will get the hang of it fairly quickly as you code. But basically, these are reserved, right? And so you cannot use them as variable names. Great. So we have covered a lot of basic topics related to Python data types, right? In the next one, we're going to start looking at lists, tuples or tuples, depending on what you want to call it, dictionaries, sets, and dictionaries in a reasonable amount of detail, right? And so that's the next lecture that we're going to take a look at. And I'll add a link to a quiz on this topic, right, to the video. So do check that out and try it out, right? So hopefully that'll help you refresh these concepts. Okay, great. So hopefully you learned quite a bit from this session. See you on the next one.